Hello, this is chapter 5, video number 3. In the previous video, we did discuss how to utilize the addition rule, and we are going to be talking about the multiplication rule in this next video. So first off, I want to get an understanding of why are we multiplying here and when would that be the circumstance. So here is our first example. We have 25% of all students at a school are freshmen. And 60% of the freshmen are involved in some type of extracurricular activity. Find the probability of selecting a freshman that is involved in an extracurricular activity. So looking at this, let's say this is the population of high school students. Well, I know that about 25% of them are freshmen, 25% are freshmen, and out of that 25%, I know that about 60, and I'm just kind of guesstimating here, I know that about 60% of them are involved in an extracurricular. So I have two things going on. First off, my first event, I need to make sure that I'm selecting a freshman, 25%. And out of that 25%, okay, well, 60% of them are involved in an extracurricular. So here is the setup for this problem. So first off, first event was 25%. 25% of my population are freshmen. And if that's where the problem ended, what's the probability of me selecting a freshman? I'm done, 25%. However, I need to also select a freshman that's involved in an extracurricular activity. So out of my 25%, 60% of them are involved in an extracurricular activity. And if I were to multiply these together, well, 25% of 60, if I were to multiply that out, I am at 15%. And intuitively, this makes sense. 25%, even if 100 of my freshmen were involved in extracurricular activities, then my answer would be 25%. However, only 60% of the 25% are involved. So out of my whole population, my probability of selecting a freshman that's involved in extracurriculars is 15%. So let's utilize this multiplication rule here with a free throw example. So here's what we got. First off, a basketball player makes 80% of all free throws. A basketball player makes 80% of all free throws. First thing I'd like to calculate is find the probability that a player makes 2 free throws in a row. All right, so looking at this, first off, we have two separate events. We have two events. We have the first free throw and we have the second free throw. All right, and we want him to, he or she, sorry, I don't mean to assume gender here, but we need the basketball player to make both of them. So probability of making the first one, 80%. All right, times probability of making the second one. Probability of making the second one is still 80%. And when I multiply those two, 0.8 times 0.8, 64% of the time, the probability that out of shooting 2 free throws, probability of making both of them is 64%. All right, let's go a little further here. So I'm going to go ahead and draw this all out, and then I'm going to introduce or just remind you guys of exponents. It'll make things a little bit easier. But we have 5 events. 1, 2, 3, 4, and 5. 5 events. And I want to know what is the probability that this player makes 5 free throws in a row. 5 free throws. So probability of the first one is 80%. Probability of the second one is 80%. Probability of the third one is 80%. Still have 80%. And still have 80%. And that comes out to be right about 32.7-ish percent. So if we're shooting 5 in a row, the probability that they make all 5 is right around 33%. So looking at this, just to remind you guys of some notation from middle school and high school, 80% to the 5th power is another way to write 80% times 80% 5 times. And you should have the exact same answer of 0.32. I know I have a problem here. I'm going to go ahead and do one more example before we get to that one. But here's what I'd like to figure out. Find the probability that the player makes 3 in a row, but misses the fourth. All right, so same thing here. We have 4 events now. We have 1, 2, 3, and 4. And we are going to say make, miss. We want to miss that fourth one. So looking at this one, first off, probability of making the first one is 80%. We have 80% again, 80% again. However, our fourth one, the probability of missing the fourth one, well, if we make it 80% of the time, that means 20% of the time we are missing it. And that comes out to be about 10% of the time. So if we're shooting 4 in a row, the probability that we make, miss is right around 10%. And that's if we do 4 in a row. All right, last one. And this is where we kind of, there is a long way to go about this, and there is a short way to go about this. And I want to go the short way. But let's go ahead and get some intuition here. Find the probability that the player misses at least one free throw out of 5. Ooh. So whenever I see the words at least, that is a huge indicator that we're going to have some careful calculations here. So here's what I could figure out. Find the probability that a player misses at least one free throw. Well, we would have to add up the probability that we missed one, plus the probability of missing 2, plus the probability of missing 3, plus the probability of missing 4, plus the probability of missing 5. And this would have to be our calculation, the probability that we miss at least one. We'd have to calculate all of those, missing 1, 2, 3, 4, and 5. But here's the shortcut. Not necessarily a shortcut, but something I want you guys to think about. Well, we have all of these different scenarios, missing 1, 2, 3, 4, and 5. Well, we only have one other possibility, right? That'd be the probability of missing 0. And I know that all of these add up to 100%. So let's use that to our advantage here. And we have already calculated this in a previous problem. We've already calculated this in a previous problem. The probability of missing 0 out of 5, we calculated right here. That's about 32%. I'm going to go ahead and round it to 33% if that's okay with you guys, just for simplicity of the problem. I know that this is going to be 33%. That was an easy calculation 2 problems ago. Now, here's the deal. This is what I'm really after. And I know that this piece, all of those added together, plus this, have to add up to 100%. So here's my answer. And I did round this just a little bit, if that's okay with you guys. Don't do this on your MyMathLab. But since this probability is 33% of making all of them, the probability of missing at least one is right at 67%. All right, so here's what we did in this video. We discussed the multiplication rule. And we're not talking about probability of 2 separate things on one event. With this, we're talking about multiple events occurring in a row. Picking a freshman, extracurricular. Making 2 baskets, making 5 baskets, making 3 and missing 1, missing at least 1. So this is when you would utilize that multiplication rule.